Good day everyone, and welcome to another learning lesson in mathematics. I am Teacher Trisha, your math friend, and I will be your guide in sharpening your problem-solving skills and enhancing your critical thinking skills in facing challenges in mathematics. Are you ready? Is your pen and paper ready? Great! Let's begin a fun and exciting lesson. Now, let's explore what's in finding the sum of the terms of a given arithmetic sequence.
For this lesson, you are expected to first, find the sum of the first n terms of an arithmetic sequence, and second, solve word problems involving arithmetic series.
In the previous lesson, it was discussed that to find the end of an arithmetic sequence, the formula a sub n equals to a sub 1 plus d times n minus 1 can be used. In this lesson, we will discuss how to find the sum of the first n terms of a given arithmetic sequence.
For example, how do we compute the sum of all the terms of each of the following sequences? First, we have 1, 2, 3, up to 100. Second, we have 5, 10, 15, 20, up to 50.
Adding manually the terms of a sequence is manageable when there are only few terms in the sequence. However, if the sequence involves numerous terms, then it is no longer practical to be adding the terms manually. It is a teacher's work to do, right? Thus, this lesson will present to you a formula that will make the computation faster and easier. To let your experience in getting the sum of terms in a sequence manually, let's do the following.
First, we have find the sum of the first 20 natural numbers. By listing all the natural numbers from 1 to 20 and adding them, we have 1 plus 2 plus 3 plus 4 up to 20, and we have 210. Thus, the sum of the first 20 natural number is 210. Second, we have find the sum of all the terms of the sequence 5, 10, 15, 20, up to 50. By listing all the terms of the sequence and adding them, we have 5 plus 10 plus 15 plus 20 up to 50, and we came up with 275. Thus, the sum of the terms of the sequence is 275.
What if you are asked to find the sum of the terms in the sequence 1 to 10,000? There are 10,000 terms to be added one by one to get their sum, right? In getting the sum of an arithmetic sequence, we will be using any of the following formula.
First, we have a sub n is equals to n over 2 times a sub 1 plus a sub n. Note that this formula is used if the first and the last term is given, where S sub n is the sum of the first n terms. N corresponds to the nth position. A sub 1 is the first term of the sequence, while a sub n is the last term of the sequence.
On the other hand, if the last term is not given, we will use the formula
S sub n is equals to n over 2 times the quantity of 2 times a sub 1 plus n minus 1 times d. Note that This formula is used if the last term is not given, where S sub n is the sum of the first n terms, a sub 1 is the first term of the sequence, and d is the common difference.
Now, let's take a look at this example.
First, we have find the sum of the first 20 natural numbers. We have now our e sub 1 is equals to 1, our e sub n is equals to 20, our n is 20, and we have to find our s sub n. We can see here that our first and last term are given. So the formula that we're going to use is s sub n is equals to n over 2 times a sub 1 plus a sub n. Then, we're going to substitute the given terms. So, s sub 20 is equals to the value of our n is 20 over 2 times the value of our a sub 1 is 1 plus the value of a sub n is equals to 20. Next, s sub 20 is equals to 20 divided 2 is 10 times 1 plus 20 is equals to 21. Then, s sub 20 is equals to 10 times 21 is equals to 210. Thus, our s sub 20 is equals to 210. Our second example is, find the sum of the first 16 terms of the arithmetic sequence 8, 11, 14, 17, 20, and so on. Then we have our given. Our a sub 1 is equals to 8. Our n is equals to 16. Our common difference is 3. And we're going to find our s sub 16. We can see here that our last term is not given. So the formula that we're going to use is s sub n is equals to n over 2 times a quantity of 2 times a sub 1 plus n minus 1 times d. Then, we're going to substitute our given terms. So we have our s sub 16 is equals to the value of our n is 16 over 2 times a quantity of 2 times the value of a sub 1 is 8 plus the value of our n is 16 minus 1 times the value of our d is 3. Then, s sub 16 is equals to 16 divided 2 is 8 times 2 times 8 is equals to 16 plus 16 minus 1 is 15 times 3. Next, s sub 16 is equals to 8 times 16 plus 15 times 3 is equals to 45. Next, s sub 16 is equals to 8 times 16 plus 45 is 61. Then, s sub 16 is equals to 8 times 61 is equals to 488. So, our s sub 16 is 488.
After knowing the concepts and finding the sum of an arithmetic sequence, let's try to answer this exercise.
Find the sum of the first 30 of the arithmetic sequence 1 plus 3 plus 5 plus so on. Then, we have our given. Our a sub 1 is 1. Our n is 30. Our common difference is 2. And we're going to find our s sub 30. Since our last term is not given, so the formula that we're going to use is s sub n is equals to n over 2 times a quantity of 2 times a sub 1 plus n minus 1 times d. Next, we're going to substitute our given terms. So we have s sub 30 is equals to the value of our n is 30 over 2 times 2 times the value of our a sub 1 is 1 plus the value of our n is 30 minus 1 times the value of our d is 2. Next, s sub 30 is equals to 30 divided 2 is 15 times 2 times 1 is 2 plus 30 minus 1 is 29 times 2. Then, s sub 30 is equals to 15 times 2 plus 29 times 2 is equals to 58. Then, S sub 30 is equals to 15 times 2 plus 58 is equals to 60. Then, S sub 30 is equals to 15 times 60 is equals to 900. So our E sub 30 is equals to 900.
Now, let us see what you have learned from today's lesson by applying this in solving the given word problem.
The problem is, Jane was saving for a pair of shoes. From her weekly allowance, she was able to save 5 pesos on the first week, 9 pesos on the second week, 13 pesos on the third week, and so on. If she continued saving in this pattern and made 43 deposits, how much did Jane save? Then we have our given. Our E sub 1 is 5 pesos, our N is 43, and our D is 4. Then we're going to find our S sub N. Since the last term in this problem is not given, then the formula that we're going to use is S sub N is equals to N over 2 times a quantity of 2 times A sub 1 plus N minus 1 times D. Next, we're going to substitute the value of our given terms. So we have the value of our N is 43, so we have 43 over 2 times 2 times the value of our A sub 1 is 5 plus the value of our N is 43 minus 1 times the value of our D is 4. Then, 43 divide 2 is 21.5 times 2 times 5 is 10 plus 43 minus 1 is 42 times 4. Next, 21.5 times 10 plus 42 times 4 is 168. Next, 21.5 times 10 plus 168 is equals to 178. Next, 21.5 times 178 is equals to 3,827. So the value of our S sub 43 is equals to 3,827.
I hope that you learned a lot from today's lesson. Always remember that math is always part of our daily lives. God bless!